Okay, so yeah, welcome everybody. My name is Christopher from the Technical University of Munich. In the next minutes, I quickly want to introduce the SAPHEA calculation model for the early assessment of large-scale heat pumps in the context of geothermal district heating networks. So what you will see in the next minutes is that the tool can be used in two ways. On the one hand, it's part of the general SAPHEA web platform, where also the other tools like GeoFires can be directly used, but we also have it as a standalone tool. So therefore, depending on your preference, you can either access it as shown here, and then on the left side, the window will pop up where you will see the different input parameters. You see already some first default values, and then you can start calculation on the right side. The results will pop up. But I think also to explain a little bit the general workflow and motivation of the tool, I also then want to show that in the framework of the standalone HTML-based tool, which you see here. So just to repeat very briefly, why do we want to assess large-scale heat pumps? As you can also read in more detail on the wiki page, you can, next to the standard case where you use geothermal for direct use for the district heating network supply, install a heat pump for two purposes. On the one hand, to increase the thermal capacity of your geothermal project, as shown in the middle, or like is shown on the right, that you use it to utilize insufficient temperatures. So if the production temperature of your geothermal project is not matching with the supply temperature of your district heating network. And so therefore, also, for example, by using some of the output data which you get from the GeoFires tool, you can use now this heat pump calculation model to assess the integration potential of large-scale heat pumps for your district heating network. And so you see, as shown for the three cases here with the figure, you can choose between three calculation models. So the first one, the direct use, is just one way that you can double check if you can operate your system without the need for a heat pump. So for example, if you specify then the geothermal production temperatures, your supply and return temperatures of the district heating network, you would then, for example, get as a result a certain thermal output. And like in this case, where we have a production temperature of 100 degrees C and a supply temperature of 85 degrees C, that you can use it directly. But if you would like to increase the capacity of your geothermal project, because like the 12 megawatt is not sufficient for the size of your district heating network, it already shows you that you can investigate the integration of a large-scale heat pump with the capacity increase module. At the same time, if you would now already type in that you only have a production temperature of 70 degrees, it will tell you that you need heat pump, otherwise you could not integrate your geothermal source in your specified district heating network. So therefore, like then if you want to assess a heat pump, you could now go for the capacity increase case, where then again you need to specify certain parameters like the injection temperature, which you can reach for your project, the supply temperature, return temperature, and so on. So also there, more information about the parameters can be found on the wiki. And like if we type in some of the standard values, for example, you now get as a result some insights, for example, that with the heat pump, you could provide 12 more megawatt heat to your district heating network. So therefore, instead of just having 10 megawatt thermal load without a heat pump, by the means of the large-scale heat pump, you would increase the capacity of your geothermal project to 23 megawatt. And of course, then it's also about some estimations of the economics, and this is mainly related to the COP of the heat pump and the investment costs. So the COP is the ratio between the required electricity in order to provide the heat to your district heating network. So therefore you see for the temperature lift in your specified scenario, you would have a COP of 3.5, which means in order to supply this up to 13 megawatt thermal with your heat pump, we would need up to 3 megawatt electricity to drive the heat pump. And you also get some estimations about the specific investment costs of the heat pump and then the overall estimated investment costs. And so also the tool, in case you would type in for example, values which don't make any sense, then you will already get directly a warning. Also, you're not able to even calculate it. But then, you can also see, for example, if you would now have a more modern district heating network, which requires only a supply temperature of 75%, then the COP increases of your heat pump. So now you have a COP of up to 4.5, and there, because it's a lower temperature lift. And therefore, we hope that these calculation modules can give you some first insights about the expected size, the expected performance of your potential large-scale heat pumps. And if you have any further questions, check out the wiki or also look into the contact details provided there. Yeah, thanks a lot.